Today I will be talking about verification and validation in VLSI design, concept, timing, and industrial terminologies. So today I will discussing a critical aspect of VLSI design, the concept of verification and validation. This term often used interchangeably, but in the semiconductor industry, they they refer to distinct process with different goal, tools, and timelines. We explore this difference where they occur in front-end and back-end design flow, and understood the various specialty specialized terms like post-silicon validation, formal formal verification, and more. Let's start definition with the definition. Ver- Verification answer the question: Are we building a product right? It ensured the design met the specification. Validation, on other hand, asks: Are we building right product? It ensured the final chip work in the real world use case. So verification is specification driven and validation is user experience driven. Front-end versus back-end. In front-end stage, we deal with RTL coding, simulation, and early design verification. This this is where functional verification, accession-based checking, and test-bench simulation occurs. The backend involves synthesis, layout, and sign-off. Here we perform timing verification, DFT insertion, DRC LVS check, and post-silicon STA, post-layout STA. So verification both front spans both front-end and back-end, whereas validation usually stand after tape-out in the lab on the silicon. Timing verification. On one important type of verification is static timing analysis or STA. Pre-layout STA happen during the synthesis where wire deals wire delay wire delay is are estimated. Post layout STA use parasitic extraction after place and route for accurate delay modeling. This analysis ensures the design met setup and hold timing constraint, avoiding the functional failure in silicon. Type of verification. Let's briefly discuss of verification techniques. Functional verification uses the test bench and simulation to check logic behavior. Formal verification uses mathematical proof to ensure properties hold without running the test case. So for functional verification use test bench and simulation to check the logical behavior. Formal verification using mathematical proofs to ensure properties hold without running test case. Equivalent checking ensures that the synthesis netlist is functionally same as the RTL. Coverage analysis measure how thoroughly the design was tested. These are the mostly used in pre-silicon in front-end and back-end. Validation technique. Validation techniques ensures the chip work under real-world conditions. Post-silicon validation occurs after fabrication using tools like logic analyzer, oscilloscope, and ATs to test real chips. FPGA prototyping helps validate system level functionality before fabrication. System validation involves running software stacks, peripheral test, and integration with real interface like DDR, USB, or PCIe. Validation catches issues not possible to detect in simulation, such as signal integrity, temperature variation, and noise effects. Summary table. Question: in verification, are we building it right? In validation, are we building it right thing? Are we building the right thing? Driven by verification is driven by specification and validation is driven by user requirement. Verifications tools are simulation, STA, and formal, and validation tools are lab testing, FPGA, and ATs. Verification phases are pre-silicon, front-end, and back-end. Validation phase is post-silicon. Verification example is functional simulation, timing check, and validation examples is real chip testing and field test. Here's a summary comparison of verification and both essential, but they occur different stages and use different methods. Real world analogy. Think of building a car. Verification is like checking the design drawing, simulation, and ensuring that all the parts met the engineering specification. Validation is test driving the actual car. Make sure that perform well on a road under different conditions. To conclude, verification ensure correctness to the specification of both front at both front-end and back-end stage. Validation ensure usefulness and reliability in real-world scenarios after silicon fabrication. Understanding both is crucial for high-quality first-pass silicon success. Thank you. I'm happy to take any question.